Okay, so Tiffany is counting colonies on her plates, and she's using a Sharpie to touch the bottom of the plate at each place where she sees a colony, and that lets her know where she's counted a colony and where she still needs to count. If she loses track of her count, she can just wipe these Sharpie markings off with ethanol and start over. And when she gets to the last colony, she makes a note directly on the plate how many colonies were counted. I have recorded how many colonies were counted on different dilutions of the plates, and now I'm getting ready to analyze this data to arrive at an estimate for the number of cells in the original colony. KaleidaGraph there's a lot of buttons to push, and it's hard to remember all the details. That's why we made this video. You want to enter your data, call the first data column dilution. This is the dilution step that you used. And you only need to have, record those dilutions for which you could actually count colonies. So I'll put in here dilution number 6, dilution number 6 again, because it's in duplicate, dilution number 7, dilution number 7, and then dilution number 8, and dilution number 8. And for each of these, I counted a certain number of cells or colonies. So colonies, and you may want to personalize it, like my strain JM10, JM101. Then we enter the number of colonies counted: 115, 132, 20, and 10. And one colony here, and then one lonely colony on that plate too. So now we've entered the data, and to plot it, we go over here to the gallery menu. We select gallery, linear, and line. And there's a little shortcut key to do the last plot that you did, which is the command button plus D. And we say the x-axis should be dilution, and the y-axis will be colonies, and we make a new plot. And right now the plot looks okay, but we want it to look better. So we're going to go over to some of the plot options. We're going to look at the variable settings, and the shortcut here is Command M. So you can either go through the menu or just remember Command M. And I want my data points to be bigger, so I'm going to select like 18 here, and I'm partial to squares, so I'm going to use squares. And I don't want the dots to be connected at this point, so for line style I'm going to say none, and then you can choose a different color, orange, dark black, whatever, and you're okay. So now my data is shown on the plot. And the next thing that we want to do is we want to, what we're seeing here is as a function of dilution, we get a decreasing number of colonies. But what we are really interested in for the purpose of this lab is what were the number of cells when we didn't have any dilution. So I'm going to extend the range of this x-axis by double-clicking on the x-axis, double-clicking, and then I'll choose the minimum to be 0 here, and the maximum I'll say be 8, and I go over here to ticks and grids, and I say I only want to have 4 steps dividing the dilution step, or you could choose 8. Let's choose 8. Say OK. Now you can see we see this undiluted condition, and we see steps 1, 2, 3, 4, 5, 6, 7, 8. We only could count things at steps 6, 7, and 8, but we're going to make an estimate of how many cells there were in the undiluted condition by extrapolation. So to do that properly, we need to change the y-axis as well. We're going to double-click there. We're going to go from a linear scale to a logarithmic scale. For the minimum, we want to say 1, because that's the smallest number. And then over here, to get a good estimate for the maximum number, you want to add to this number that it's giving you here the 10 raised to the 6th power for this 6th step dilution. So we'll say 100 e to the 6th. Okay, and now we we can see that with the logarithmic axis, these dots now are connected by a nearly linear pattern, and we can see that the extrapolated version will intercept the y-axis somewhere over in the 100 million range. Now, to find out a more precise estimate of this extrapolation, we could just use a ruler. We're going to use curve fitting. So select curve fit and go to General and say Edit General. And then you can choose one of the pre-programmed ones here and just rename it. I'm going to call this one Colony Count. And then you want to press the Edit button. And this is the equation of a line. And we need to replace this with a new equation for what happens when you dilute the cells. Variable. And then over here, off to the right, you should add semicolon to separate estimates for your parameters. So M1, our estimate for the number of cells in the colony might be something like 1 million, so 1E6 in scientific notation. M2, now we're done defining this new curve fitting routine colony count. We say OK, and we have to go back to the curve fit, select colony count from the general option of the curve fitting menu, and now select our data and say OK. And now there's some math that gets done, and we get an estimate for connecting these dots as precisely as possible. We get a correlation coefficient of R is 0.99, which is really close to 1, which is what we wanted to see. Here, this M1 parameter, that's the number of cells that we have in the undiluted condition. Right now, we don't see the intercept because the curve fitting is just within the range of the data. But you can go over to curve fit and select curve fit options and say extrapolate fit to axis limits. And then the curve will get extended all the way out here. It's really hard to see these numbers, and the way you adjust that is you double click on them. We're just fixing up and making the graph look nice. So we'll select 18 point font there, 18 point font here, this number, this label, that could be made bigger too. OK, and colonies, oops, did the wrong thing. Dilution, say OK. Colonies, 18 point font, nice and big so we can see it. And then you might want to relabel the title of your graph. You say Martin's totally awesome data, exclamation point, say OK. And yeah, now the data looks a lot easier to see, and importantly, the meaning of the data is made clear because this y-intercept, that's the measurement that we wanted from the very beginning. How many cells were in that colony to begin? Now remember, on the plates, we only plated 200 microliters of the 1 milliliter available. So we need to multiply this number by 5 to compensate for that partial sampling that we did. And so this 8 million becomes really 40 million cells. 40 million cells, that's a lot of cells.